Yeah, I think we're ready to start. All right, hey everybody. Welcome, thank you so much for coming. I'm Tobiah Zarlez. Over there is Katherine Harris. Over here is Adina Shanholtz. Shanholtz, excellent.
Yes.
So we are all evangelists of Microsoft. We get to talk game development all day and have awesome fun times. We're here to talk about Unity development. So I asked it before, but just a show of hands, who's like opened Unity at all right now? Who's done it before? All right, like maybe a third of you. Great. So we're just going to start really basics, kind of go over what Unity is real quick. We have a very short amount of time, so I'm going to end up talking too fast for you guys to really retain the information, and I apologize on that, but I'll have the source code at the end so you can look through it at your own pace and kind of figure out, what I did and learn more about Unity, as well as we have Kat and Adina here that if you did want to pull out your laptop and try to follow along, they can sit with you and help you out as you're going by, even if I'm talking a mile a minute, or I'll try to talk as slow as possible.
If you guys have any questions, let us know. We will come over to you and whisper things in your ear.
Good things.
Good things, like helpful things.
So, Unity is a game engine. It is a framework for you to make games. I was mentioning before that engine technology is just night and day compared to what it used to be. You used to have to work so hard just to get something on the screen that can move around, and Unity eliminates so much work now. You have 3D, you have physics built in, it's literally drag and drop for a lot of stuff, and then when you do have to touch the scripting, which we're going to do so a little bit of coding today, it's actually pretty simple stuff. So even if you've never done any coding before, Unity should be easy to jump into. So with that, I'm just going to jump into it right here. When you open it up, you get this new project screen. We're going to do a new project. We're going to make a collecting game. And I should save it on my desktop just because. It has presets for doing 2D or 3D. We're going to make a 3D game, so just click that right there. But don't worry about that too much, because the difference between those two is really more settings than the actual game itself. So I wanted to take a moment, now that I'm actually in Unity proper, kind of give you a tour of what's going on, because it's going to be really intimidating for some people. Anyone use any 3D modeling programs before, like Maya, Blender? Okay, good amount of you guys. So you guys will be a little bit less scared. The people who created Unity came from a 3D modeling background. So they actually made a lot of tools and keyboard shortcuts very familiar and comfortable for someone coming from that space. And so then programmers come into it and they're like, what is going on here? I'd recommend having a 3-button mouse. You can hold down right click to kind of turn around, middle click lets you pan around the world. In this top spot right here, I have my scene, which is kind of my empty 3D world I've created. The game view is kind of a real-time preview of what the game's going to be. I should zoom in on this here. The hierarchy right up here is the objects that are in my scene. The objects is in a programming construct kind of way. Projects is just the asset file of what kind of files are in this project right now, since there's literally nothing. Just an example, I have my blank scene it created right here. If I just save that real quick and I say scene, it appears down here because now I have a new scene file saved, and all a scene file is a collection of objects in the scene. It starts off with a main camera, which is a camera is what the player is actually going to be seeing through. So I have this kind of object in the world, and it shows, you can see if I zoom out a little bit, that it has this kind of lines. It might be a little bit hard to see from up there, but that's kind of like what the player is going to see in the world. And then a directional light is just, a sun ray coming down, lighting up the scene. So let's actually add something here to make it a little more interesting. You can import any 3D object you want into Unity, but if you have like just really simple shapes, it has a bunch of primitives, they're called, that you can put in. It's great for making a very basic game, basic level, or white boxing it's called, kind of blocking things out and then adding better looking art later. So I want some ground right now, so I'm just going to add a plane. And I'm going to, so when I add the plane, you see it immediately in the editor right here. You see when I highlight it, it shows the vertices right there of the 3D object. In the hierarchy here, now it's added the plane object. And then in the inspector right here, I kind of have all of the properties of the object. And this is kind of a really important concept to grasp. So as I said, Unity is a drag and drop editor. You kind of drag something into this world here, but then these properties where you can customize and do whatever you want. And that could be just as simple as attaching a script, and then that script is going to run on that object and do that code. We'll do that in a little bit later. One thing to note right now for this is that every single object has a transform, and all a transform is what position it is in space. So let's see.
And rotation and scale.
Yeah, so it's at this weird spot right now, so I'm just going to put it 0, 0, 0, and I will keep the basic scale that it has, and it just floats right there. And then I can also rename it, call it ground. That'd be simple. All right, now let's make a object that we'll call our player. So let's just make a simple cube, and I'll rename it to player. I can either rename it here in the hierarchy or up here in the inspector. I can just call that player. So these other components they're called right now is the mesh, that's just a 3D object. The collider, that's for physics. We'll deal with that in a little bit. But as I said, I'm going to gloss over a lot of stuff, so I apologize if I go a little quickly in sake of time.
Any questions, let us know.
Yep.
Just one.
Yes.
Coordinates are based on center of object or bottom of object?
It's actually, you can set it. I think default is center for most things, but you can also set the anchor to whatever you'd like. This is the follow-up to that is that Unity tries to make it so 1 unit in Unity is 1 meter, to kind of how you're thinking about scale. So I'm going to set this cube in the middle right here, and I'm going to set the Y to 0.5 so that it's kind of floating up here, so it's not down in the middle of our ground. It's kind of hard to see right now because it's white on white, but I will fix that right now. So in my project right here, I'm going to create a new folder. We call it materials, and let's make our life a little bit easier and create a new material right there. And I'm not going to grab any texture files. I'm just going to make a color, and I'm going to call this, there's my rename, layer material. And I'll do the same thing again, create material. I could right click down here and create it, or I believe I can go to asset, create material up here. There's always 2 ways to do things in Unity. It's not strictly true, but often is. I'll just set the color to blue. And now, just as simple as drag and drop, I'm going to drag this ground material onto the plane object, and I'm going to grab this player material onto the player object, and now that has the new material I've chosen. It's called a material because this is just a really simple color, but you can add texture, you can add normal mapping, you can do really, really advanced 3D modeling stuff, whatever you want to do, it's capable of doing it. So this cube right here, you can see in the mesh renderer, it now has the shader selected of this material that we just did. So we're modifying that renderer component just by dragging and dropping the new material on it. All right, what's my next step? All right, let's add some physics. So I'm going to add component. I'm going to go to physics. Now, there's 2 kinds of physics in Unity. Physics, just called physics, which is 3D physics, and physics 2D, which was added later when they added 2D stuff to the engine. They're 2 completely different physics engines that do not interact with each other. So always note, am I thinking about 3D physics or 2D physics? And there's reasons why, but I won't go into an explanation because I'm glossing over stuff. So no, I didn't want that. I did the wrong one. I want to add a rigid body. And a rigid body just tells Unity that, okay, apply some gravity to this. So if I move the ball up a little bit and I hit play, you can see in the game view right down here, which is what the camera is seeing, how the thing just plops down on the ground. Because now, just by adding that one component, it now knows that has gravity, and automatically the plane knows, hey, I'm an object, I have a collider. When I hit that, I stop. Now, let's add some code. So I'm going to create a new folder for scripts. That's not necessary, but it's nice to create folders just to keep your project clean. And we're going to create a new C# script, and we'll call it player controller. Just put player controller. And when you double click it, it'll automatically open your editor of choice. Default editor for Unity on Windows now is Visual Studio, Microsoft tie-in.
Shameless plug, shameless plug.
Yeah, shameless plug right there. But there's also MonoDevelop, which is available for PC and Mac. You can also use Visual Studio Code, which is our lightweight editor. Some people use Sublime. Pretty much anything that can do C#.
What's the difference between C# and JavaScript?
Great question. So you can use different languages on Unity. You can use C#, you can use their JavaScript variant, and Boo, which is supposedly inspired by Lua, but not really. And on a per object basis, they could run those scripts in whatever appropriate language. It gets kind of weird when the scripts need to talk to each other in different languages. So from your development point of view, in a basic level, not much, but in the back-end level, it's taking that JavaScript and turning it into C# anyway. So something like 80+% of Unity developers just do entirely C# because weird errors might happen when the JavaScript's trying to be converted into C# anyway. So most people just jump into what Unity's actually doing on the back end.
JavaScript is also pragma strict, so if you're used to doing JavaScript to be like, variables, I'll define them later, whatever. It's just like, no, you actually have to define your variables. You have to make the JavaScript look like your C# script anyway.
Yeah.
Just real quick then, like if you want to make like a web game, like is the C# then translate to JavaScript? Or do you usually use the website?
Excellent question. So what's amazing about Unity, and like literally jaw-dropping amazing, is that you code it in Unity, you make it in C#, you have one game, and you can go literally anywhere. It can export WebGL. It can make an Android, iOS, Windows Store app. It will do all of that conversion for you in the background. You don't have to worry about that at all. So I have this new script right here, and when it creates that, it automatically sets up kind of a basic structure. So anyone has ever touched C# before? Any seen C#? All right, most of you. But so I'm inheriting a bunch of stuff from this mono behavior class. If you don't know anything about object-oriented programming, just don't worry about it. Just know that your code's going to live within this little structure right here, this class with the one I just created. And with default sets up these functions. For start, that's going to run once when you first start the app. So you can have code there to initialize something. And then update is something that's going to be called every single frame. So if you're doing 60 frames a second, that function will run that code 60 times a second. So we're going to add a new function called fixed update. Now it's a little weird of a concept because there's update and there's fixed update. Fixed update runs X times a second based on what you define your project as. So you say, all right, I want this to run at, let's say, 30 calculations per second, and it will run exactly 30 times. Even if the frame rate was 25 per second, 50 a second, 51, because update, it's kind of variable. You don't know how often it's actually going to run, but fixed runs on a more fixed interval. So we're going to define some functions. So variables, I mean. So we're going to set up a float for move horizontal and float for move vertical. And then we're going to set their values to input, which is a built-in Unity function, get access, and you can see right here in Visual Studio, it has some autocomplete stuff for you. So even if you don't know what's available, you can kind of just mess around with the code and see what you can get access to.
Like that.
So get access, and then I'm going to call the name of this, or get the name of the axis horizontal. So there's automatically a built-in input function, and it can automatically get the horizontal axis. So if I had a game controller plugged into this, it knows the stick, okay, I'm going to get a value between, I believe it's -1 and 1 of the horizontal, and as you might guess, I'm going to get for the vertical. And what's also great is that it's set up where it isn't just if you have a game controller plugged in, vertical, gotta spell it right. But for just your keyboard, it'll know, okay, well, if he's pressing the left key, then it's going all the way to the left, and it'll just set that to -1. So it makes it multiple kinds of input can work. So now we have these two values. We want to turn this into a vector. This is where math gets involved. A lot of programming, all it is just really advanced trigonometry. Not even kidding. So we're going to do a three-dimensional vector. Since we're in three-dimensional space, we're going to call it movement. And then we're going to set that equal to a new three-dimensional vector. And we're going to have it the horizontal movement for the x. We're going to say 0.0 f in the y because we don't want to move up and down. And then we do move vertical. Question in the back.
You make that way bigger.
Yes, I can, and I'm sorry. Unfortunately, my tool doesn't allow me to zoom as I'm typing, so hopefully you can see it a little bit better. This is the horizontal variable. We get it, the horizontal axis from the input. We do the same with the vertical, and we turn that into a three-dimensional vector object that is a new three-dimensional vector object for the horizontal we just got 0 in the y, and the vertical we just got in the z. Yes, that's true. I could do that. That's a smart idea. You're smart. All right. So now we got these variables, we want to actually do something with it. So remember how before I emphasized that every object has a transform right here, and that transform defines the exact position it's going to be in space. So if we go into the code here, we can get that transform. Now normally if you're looking for a component, you have to do get component and search for it and find a specific type. But because every single unit object has a transform, there's a built-in variable for that that's just transform. And that transform function has or if that transform component has a bunch of functions built in, so we're going to do translate, which is moving that transform. And we're going to put in movement, which is the 3D vector that we just made. So it's going to know, okay, whatever direction that they're trying to go, we're going to go that way. And we're going to multiply it by time.delta time. Anyone know why I would do that? Anyone know what delta time might be? Exactly, time since last frame. So again, we want to make sure that it's when this is updating, if it doesn't run, so if the game is laggy, we don't want the movement to be laggy. We want the thing to move at the same rate no matter what, because even slight differences can kind of mess it up. So we do time.delta time is the time since the last time fixed update was called.
Question?
Yes. Where was the question?
I was just going to say that this is on the fixed update.
I still do it anyway because it can still be some problems because a fixed update, it wants to run at a certain time, but it might still have a delta time between them that variables between, because it's not perfect. All right, so with that, I believe I can hop back into Unity, and I just hit the play button up here. I kind of played that before, but if you hit this play button right up here, that kind of immediately compiles your game and runs it right within Unity. So I can hit maximize on play right down here as well. So it'll take this game view and make it all big when I play. And you can see that I didn't do it quite right. It should have. Oh, nope, I didn't. Haha. Actually, I have to drag the script onto the game object. And you can see in the player, I have the player controller script right here.
Now you can control the player.
Yep. And now it's moving. Yay. Really, really slowly. So let's fix the slowness part. So let's go back to our script. And outside of the functions right here, let's create a new public variable speed. Now, public means that you can see it outside the scope of this object, and that's important. I'll show you why in a moment. But now I can take times delta time, I can just multiply that by speed so that it'll increase, right? So if we make speed 10, it's going to move at 10 times the rate it just was, and that might be more fun for our game. Now, I could, in the start function, just say speed equals 10, but Then whenever I want to, tweak that, I got to open up the editor, I got to tweak the code, I got to find the line where it's defined. Unity's really awesome, and it understands public variables. And suddenly, down here in the script, it exposes to you that speed variable, and I can set the value in the editor, which is great because the programmer on the team can kind of set up some variables, and then the game designers and the level designers, or even the artists, can tweak the values and make it work for what they want in the game. And now, fast-moving
fast.
cube
We
that when
just
it
made
falls off the edge, it falls.
We just made Sonic, guys. I hope that you guys enjoyed.
So let's talk about the camera. So we have the camera right here. Now I can manually move it, and you can kind of see now in real time on the bottom there how it's being adjusted. And I can rotate it. It moves around. So let's set it up at a decent position with some numbers I cheated ahead of time. I wrote my notes. Set this to 0 and that to 45. All right, nice top-down view. Now we do this. It's kind of, a top-down view of the game, but it's still not moving with our object. Well, everything in Unity, you can drag onto each other and make things a child object. So I just dragged the main camera from the hierarchy right here onto this cube, which is our player, and now it is a child of the player. And because of that, its positioning here is now relative to the player. So that when I set this to 0.5 and this to 10, now when it moves, or the player moves, the camera also moves as well. This is really handy. You can set up some really interesting relationship dynamics between your objects. All right, so we got the camera working. Now let's make it so we don't fall off the edge. All right, so let's make this world a little bit bigger first. Scale 1. All right, so let's add a new game object. Make a cube. How big did I say I was going to make it? All right, so I'll call this, first let me rename this to player. Okay, I'll call this West. Zero that out real quick. Let's mess with the scale. So let's make it really big in the X. Like, let's make it 20. We'll make it twice as tall. And now in the the X position, let's make it 10. No, not the X. I want the Z. 10. There we go. Save that, and now I can just duplicate it. I can make that -10. I can duplicate, and I can call this East. Not Easter. It's not a bunny. Duplicate that again. Make the scale 1 in that, 20 like that, 0 in the Z, 10 in the X. Call it South. Give it.
See, the best thing about game
And then
making
I'm going
is
to call
you
this
define your
last one
direction.
Catherine. What's nice about game development is you can name it anything you want.
I like to name mine Dennis.
Yes. So now we have some borders, and because these are cubes and Unity primitives automatically adds the box collider to it, so it knows that there's an object that will collide. So now we are nice and safe in our box, in the box thinking. That's what we're teaching you today. And I can create a new blank game object, and I'm just going to call this borders. Now this game object doesn't have anything attached to it. It's just a transform, But for our purposes, it's really going to just be a collection of these borders right here. West, east, north, Ed, Catherine. And I'm going to drag it onto here, and that way I can collapse it, and those objects are not in my way. Everything in Unity is a game object, even just, your folder of things, everything is the same. You can add components, do whatever you want, right? So I could also move, these borders now, and just as I could show you in the editor, if I move them up, it would move all 4 of them. If we ever wanted to take the borders away, play it in extra hardcore mode or something. Alrighty, what's next in my notes? Collectibles, we actually have to do something in the game that's fun. So let's make it a game, add a goal. We're gonna add a nice cube right here. Let's add it to 0, 0, 0. Gonna zoom in right here so I can see it. I'm gonna take my player real quick. I'm just gonna uncheck right here in the inspector. I know it's kind of hard to see in the back. There's a little checkbox right here. That kind of disables objects temporarily, just so I can see this cube I just made. And I'm going to raise up a little bit, and I want to rotate it in, what would I? There we go.
45, 45, 45.
Yeah, something simple like that. Why do I need notes right now? 45, 45.
No, not scale, rotation. Rotation is 45, 45, 45.
There we go. Make it a nice Mario Kart style power up. And I'll call this power up. Now let's make a new script. And we're going to call this item controller. Double click that, opens back up. So in this script, we're just going to do really, really simple. On update, don't need to worry about
Laggy spinning items.
yeah, just going to rotate. New vector 3. We'll rotate it 15 degrees, 30, 45. Nice spinning all 4 axes. And then yet again, we're going to multiply it by time.delta time just to make it look nicer. And now I'll run it back in Unity. And if I hit play, oh, I had disabled the camera. That's funny.
You have a laugh track, guys.
I don't have a laugh track. I'm not being funny.
Well, it's mine. I
I'm in
whoa,
the, because I was in the player was in it. Let's pull this back real quick. It's like doesn't know how to collide with it. So now I did the same thing again twice, guys. I'm terrible. Have to actually take your scripts and add them to the object. But you notice how I did drag that right from the project right here right into the inspector as well. You can just kind of drag and drop whoever works for you. And now I have a nice spinning object. But as you saw when I was colliding it before, when you hit it doesn't quite know how to deal.
I like this game.
We want to make it a trigger. So in the box collider right here, normally when it collides with something, the default behavior to that is actually collide and stop it. But when you make it a trigger, it'll actually pass through into the box collider, but then will trigger something in code. So we're going to make that a trigger right here. But now before we actually do that code, I want to create a prefab. Anyone know what a prefab is right now? No one? All right, excellent.
No,
This is
that guy totally knows what a prefab is.
Excellent. Well, the rest of you can ignore the next few minutes. So prefab is one of the most important concepts in Unity. Once you can really utilize prefabs, your games can go, I'm sitting here all day drag and dropping a single object till I can actually develop a whole entire game. Because when you make an enemy in a game, you don't want to individually code each enemy. You want to make kind of an enemy type. I want all my snakes to behave the same way. I want all these houses to be similar. I want you have these collections of scripts, shaders. different things you want to put in a game object that you want to repeat, that you just don't just want to duplicate over and over again.
Which, if you do, and you do destroy the original, well, there goes all of your spawning.
Yeah.
Which I have made that mistake and agonized over for it for a day, and then went, oh, I totally forgot prefabs exist.
So,
For a reason. Sorry.
take your power up, and we're just going to drag it into the hierarchy. Drag it into the project. So normally you're trying to add stuff into the hierarchy, but this way we're going to go the other way around. And when we do so, we create a new file called PowerUp. And now you'll know you did it right because in the editor, it'll now be bluish, which is, again, really hard to see, but it'll be a slightly different color. They could have made that more noticeable, but now what's really cool about prefabs. Well, first off, let me duplicate this real quick. I'll do the reveal in a moment. So let's make a new folder, just like we did for the borders. We'll call this Power Ups with an S, and not save it, so I'll have to type it again. All right, make that a child. And now, I'm going to duplicate this. Add one over here, duplicate it again, move it over there, duplicate again. I'm just doing Control D to duplicate.
Make it all pretty. Space them out. For those at home.
All right, so I made 8 of them real quick.
Looks like a level.
Now I have multiple collectibles that I can deal with. And what's great is that these are all tied to this prefab down here, right? So if I wanted to make a change, it will affect all of them. So for instance, the rotation right now is 45 degrees. So just as an example, in the prefab I have selected down here, not an individual object up here, but in the prefab, if I made this, 80, saved it, why won't you update? Oh, because the transform's already changed. That's right. That was a bad example, Tobiah. Oh, I know. That's a great point. Let's add a new material.
Name it Catherine.
Catherine.
There we go. Fashion everywhere.
And we're going to pick yellow. I named it after you. Might as well pick the color, right?
I mean, then, we got the yellow Mario collectibles.
So now I'm going to take this material, and if I drag it on one power up here, that one power up becomes yellow, right? Now, but if I just remove that, reset. Now, if I drag it onto the prefab right here, as you might guess, in theory, why did it not pick?
Oh, it didn't save the color.
Oh my gosh.
Yeah, you see that? You see how that one's pretty color?
Thank you for the prompt there. That makes me feel better. Makes me feel way less of a failure. All right, so what's next? Collision, we did that. All right, so I've already made them triggers. So if I didn't demonstrate yet, now they're triggers. I pass through them, no problem. But we want to actually make something happen when we pass through. So we got to go back in the code for that. So back in the Visual Studio we go, back into our player controller we go, and we're going to make a brand new function that is already predefined in the previous object, but we're just overriding it. We're going to call it onTriggerEnter. And then it's actually going to pass the variable collider other. So it's passing in a collider event, and this function will trigger when we've collided with something. So we now have to do an if statement and check if the other, which is the collider we've hit, the game object, which is the game object that collided with us, We're going to compare tag. I'll explain tags in a second. Power up. So we're going to check the tag property of this object we collide with, and if it's tagged with power up, we know we hit the power up. And so then we'll say to this other game object, we're going to set active to false. So just like I did a second ago when I unchecked it and you kind of removed it from the scene, we're just basically unchecking it dynamically in code, saying we no longer need it in this game. You know, we could delete it or whatever, but for the purposes of this simple demo, we're just going to set it not active anymore. Now, if I go back into the code here, I have to show you what tags are.
This
Well,
is-
this
those are-
is my pre-made project. Here we go.
cheating project.
The cheating project.
That's the one where you pull it out of the
This
oven.
is a
it's already
cooking
baked.
show. The same logic applies. If my demos went terrible, I always have my backup I could go to. If you're ever speaking, always have that. So up here, you have tags. And there's kind of some built-in tags. And really, tags are just a string that you can assign to. There's nothing magical or special about them. But there's something that you can do because there's some kind of consistent objects you want behavior to be the same. For instance, enemies might be a tag. You always want enemies to hurt you when you collide them. They always want, when you're searching for all the enemies in a level, you know, it might be useful to have them all under the same tag, even if they're different kinds of objects they're in. There's some default tags, like for the main camera, which is, you know, that's how Unity knows, oh, this is going to be the camera I'm looking through right now. And there's even a player tag that comes by default, but we want to make a new one. So we're going to add tag down here, and we get this little tag list that's currently empty. So we have the nice little plus sign right here. We'll say power up.
Lowercase u.
I did a lowercase u.
You did a lowercase u.
There we go. We double check that, make sure. Yep, you guys are right. Way to help me. Save that. Now, if we go back to the power up, and again, we're doing it in the project here because we're in the prefab because we want all of them to have that. We can say power up. And now, when we hit our objects, ooh, that's game-like right there. All right, and now,
Oh, question, yes.
yes.
Will Unity give you enums or something that you can use so you don't have to go to those things?
Can you say it a little louder?
Enums. Will Unity give you enums instead of using bare strings? You can set up them yourself, or I think they do give you some sort of, in the editor, an enum property, so you can just set tags out.
Yeah, I believe so, yes. I believe it's actually by default, like this tag list is really just displaying an enum. Like it's I think it itself is an enum. But, all
Anything
right.
displayed, you can code yourself.
One quick thing too, just because it's maybe a little bit advanced for this talk right now, so you just have to trust me, but right now the way it's calculating all of the collision is it's taking all of these objects, we're rotating them in space, and every single frame it's kind of calculating the entire world of, okay, if the player's in this spot is it collided, in this spot it's collided. And for this scale of game, we don't notice any lag, but if we were to do this on a game scale, you might notice your game slow down to a crash. So we want to add a rigid body physics to this, just like we did the player. And so it knows, okay, this is going to be a more dynamic object, and it puts it in a different category when it's calculating the collider. But if you do that by default, now the cubes just fall, because now they have physics. So you just simply have to check, is
Don't
kinematic.
use gravity.
That says I'm basically static. And so now it knows I'm a physics object, but I don't need to move unless I'm being specifically moved in code. So a little bit of cleanup there, because I'd be remiss not showing you that. And I think I actually have some time to get into scoring. That's awesome.
You
I
do.
thought I totally would not have any time for that. Any questions so far?
You're at 20 minutes.
All right, excellent. So let's go back in here. Let's actually turn off play mode first. So let's add a new variable way up here. I'm going to add a private because we don't need Unity editor to see it. Integer, which is just a whole number. Count, that could also be called score. And if we go down into our on, trigger enter, add a new line of code here and just do count plus plus. which is the equivalent of saying count equals count plus 1, but was handier before I made it bigger like that. And so now we're keeping track internally of how many of these power-ups we collected. So now we need to actually display it to a screen. And for that, we're going to need a GUI. As of Unity, I want to say, was it 4.6? They added UGUI. If you're looking online at Unity tutorials and you search for like Unity GUI stuff, it actually can be a little bit confusing because there was this old graphic user interface system that was kind of terrible, and then there's this thing called NGUI, which is a really popular plugin that's still used today but costs like $80. And now there's UGUI, which is the Unity GUI that's much, much simpler, much better. So if you're looking for tutorials, make sure you're looking at the right UI stuff or you might get confused. But when we add components right here, see we have, not components, I want a new game object. You know, we have 2D objects, 3D objects, lights, audio. One of them is UI. So built right in, we can just add a bunch of different prefabs. We want text, something really simple. And when we hit that, not only does it add our text object, but because it automatically detected, oh, we didn't have anything else set up, it actually makes the canvas object and does all of the background stuff it needs to do to make the UI work. You can actually go through them. They're just normal Unity objects and kind of look at their code and see how they work. But again, for the scope of this talk, we're not going to do that, and we're just going to trust that it's magic and it works great.
15 minutes.
All right. So count text. And I can set this text right here to count text. So you see that the text, it's just a new component added onto this object, nothing special, just like the other ones had box colliders, whatever. It has this text component. And I can set the color down here to something a little brighter. And I can set the anchor up here. Control 10, click that. So it's the top right corner. Sorry?
Can you do like an outline on the text? So this is like-
Yes, I believe outline is one of the options. Let me set the position real quick.
You can also import your own fonts and create them that way.
Yes, and I would actually recommend doing your own fonts.
It's already come with comments.
Is an outline by default?
I don't know if you guys know this, but Comic Sans is great for games, and you should always use it. Definitely.
Yeah, Comic Sans, you're right. There we go. So now when I play the game, you see in the corner right here, we have this count text that we're displaying right here. Now we want to make that a little bit more dynamic. Again, you can mess with that settings, you can add more stuff, you can change the fonts.
You can leave your friends behind. Okay.
All right, so now we're going back to our code. Now we have to go way up here to the using. I kind of glossed over this before, but when your object's created, you do using Unity Engine, using system.collections. If you don't know much about C#, that's basically just saying we're going to use code from these objects and all of their children and all of the cool stuff. So when we say like input, it knows what that is because it's part of the Unity engine. But because we're going to reference the UI, it doesn't by default import that for optimization reasons. So we have to explicitly state we want to actually import Unity editor.ui into this so that it understands UI objects.
Isn't it engine?
It
Yeah,
is Unity
Unity
engine,
engine.
yes.
Good catch.
Good catch. We're going to make a public variable because we want to see it in the editor. We're going to call it text. Text is the pre-made function. It's in UI. You can tell that it is function. It knows it is because it has that nice blue highlight. I'm going to call it count text. Nice, add a semicolon. And now on start, we're going to say count equals 0 because we don't want the player to start with any score. That would be cheating. And we're going to say down in our on trigger, we're going to call a function set count text. Can you believe Unity automatically makes this function completely works, knows exactly what we want, and has a score updating? Nobody believes that? All right, that's not true. Let's actually set count text. All right, let's make for the first time our very own function that is not referenced by Unity. Unity's never heard of it before. It's purely us. It's going to be really simple. We're going to take the count text, which is the text object we defined up above. We're going to have the text parameter, so that's the type text. And then we're going to have that equal to count colon space, so it has a little head, and then do count dot to string, because the count is just an integer, and we want it to turn into a type string, which is text, so that the plus concatenates the two strings together, so it makes one whole string, so it'll say count 0, count 1, count 2, count 3. And now, when we play the game, actually, no, we gotta do one more step. Go.
Enter code. That's not it.
Got to see the count text right here. Has an empty variable. Got to take that, drag it onto that, so it knows the text object we're referencing is the one that we created here in the editor.
Zoom in.
Oh, yep, I got to zoom in, but I'll just zoom in case you can't see it. You have the count text right here. It's just like the speed. It's the variable we defined. I just dragged the count text object, which is the text one we created, on create, and now you can see up here that it just says default count text, but as soon as I collide with an object, it now shows our score.
Whoa! Woo! Look at that working game.
All right, that was hyper quick, I know. So pretty much at time right now. I'm sorry I had to go really fast. Unity is a really complicated tool. It does a lot of different stuff. But hopefully you guys can see that once you kind of get familiar with it, you kind of know the dynamics and how it works. It's really, really easy to use. You can do a lot of really cool, interesting things with it. If you're interested, right here down at the bottom, I have the source code for the project I just coded live in front of you with the addition of also adding a win condition. It'll say you win. So you can go to my GitHub, which is just github.com/TobiahZ. Collect them all is the name I did for this project. And you can download that source code, check it out, or you can contact any three of us, and we'll be happy to answer your questions, help you get set up. I know some people have other panels to get to, so end now, but we'll be here for questions.